Verify Wilson theorem for p is equal to 13. Now, according to Wilson theorem, p minus 1 factorial and minus 1 are congruent to mod p, where p is any prime number. Here they give that we have to verify Wilson theorem for p is equal to 13. In the place of p we can put 13, then 13 minus 1 is 12. We know that 13 minus 1 is 12. 12 factorial and minus 1 are congruent to mod p. Mod, in the place of p there is 13, so mod 13. We know that what is 12 factorial? 12 factorial is 12 into 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is 12 factorial and minus 1 congruent to mod 13. We have to prove my 12 factorial and minus 1 are congruent to mod 13. To prove this theorem, we have to consider a linear congruence a dash and 1 are congruent to mod 13. In the place of p there is 13. So we have to consider a linear congruence a dash and 1 are congruent to mod 13 such that a and a dash are belong to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now a and a dash are belong to 1 to 12 because these are non-zero remainders when a number is divided by 13. We have to consider a dash and 1 are congruent to mod 13 such that a and a dash belong to 1 to 12. A and a dash become any number from 1 to 12. Here we can consider the two cases. In the first case, if a is equal to a dash, what may be the outcome? If a is equal to a dash, then a into a dash becomes a square. If a is equal to a dash, then a into a dash becomes a square and 1 are congruent to mod 13. Now here a square, this is become a square minus 1 and 0 congruent to mod 13. In this place, if we can split it a minus 1 into a plus 1 and 0 mod 13. This means that if we divide a minus 1 into a plus 1 by 13, we have to get the remainder 0. That means 13 completely divide a minus 1 into a plus 1. So which value is suitable for a minus 1 into a? For a, in these values, if we put a is equal to 1, then we get 0 as a remainder. So we can put here 1, and if we put a is equal to 12, then 12 into 1 is 13. That means 13 into a minus 1 is completely divisible by 13. So we also here also get remainder 0. If a number is completely divisible by any number, then we get a remainder 0. So the suitable values are a is equal to 1 or a is equal to 12. If a and a dash are equal, then the values are a is equal to 1 and a is equal to 12. If now we can consider second case, that is if a is not equal to a dash. If a is equal to a dash, then we get a is equal to 1 and a is equal to 12. Here a is not equal to a dash, we we have to consider the numbers excluding 1 and 12, that are a and a dash belongs to, excluding 1 and 12, there is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We are deleted 12 and 1. Now if we consider a dash 1 and 1 are congruent to mod 13. Now if we take a is equal to 2, then in the place of a dash, that is not equal to a, because a is not equal to a dash, we have to choose any of these numbers, any one of these numbers, such that the product which gives remainder 1 when divided by 13. If we consider here 7, then 2 into 7 is 14. If we divide this 14 by 13, we get remainder 1. 13 into 1 is 13. We get the remainder 1. This is important. So 2 into 7 is convenient. The same way, if we choose a is equal to 3, then here we can put 9. Then it gives remainder 1 when divided by 13. 3 into 9 is 27. If we divide 27 by 13, then we get 1 remainder, because 13 into 2 is 26. The same way, 4 into 10 we can consider, which gives remainder 1 when divided by 13. 4 into 10 is 40. If we divide 40 by 13, we get remainder 1, because 13 into 3 is 39. So we get here also remainder 1. If we consider 5 into 8, then also we get remainder 1 when divided by 13, because 5 into 8 is 40. If 40 is divided by 13, we get remainder 1, because 13 into 3 is 39. If we consider 6, here we can put 11, which is in between these numbers. Then also we get remainder 1 when divided by 13, because 13 into 5 is 65. 66 minus 65 is 1, so remainder is 1. So if we multiply all these congruences, we get 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11. 1 into 1 into 1 into 1 is 1 mod 13. This is by property of congruences. We can multiply all the congruences. If we multiply here 1, there is no change. What is this becomes? This is 11 factorial and 1 are congruent to mod 13. Now if we multiply both side by 12, we get 12 into 11 factorial, and 12 into 1 is 12 mod 13. Now here instead of 12 we can write, if we divide 12 by 13, if 13 into 1 is 13, 12 minus 13 is minus 1. Now if here we can write, instead of 12 we can write minus 1. So 12 into 11 factorial, and in the place of 12 we can write minus 1 mod 13. Now what is 11 factorial into 12? 11 factorial is this is, and if we multiply here into 12, then that is becomes 12 factorial. So 12 factorial and minus 1 are congruent to mod 13. This is what the Wilson theorem says. So hence the proof.